So I've been a population health analyst at an insurance company for about 3 to 4 months now, and I want to go over how hard is it to actually be a data analyst. But I've learned in the first 3 to 4 months that a lot of the skills that you need to learn, Excel, SQL, R or Python, and then visualization tools like Tableau or doing things in R or Python to make visualizations, those aren't extremely hard. A lot of that you're going to learn in school depending on what you go into school for. I was a statistics major, so I learned a lot of these things beforehand, especially R and especially making visualizations in R. Personally, for me, SQL is pretty new and there's definitely a little bit of a learning curve, but after, 3 to 4 weeks of using it all the time, I would say I'm pretty comfortable using it and it's not that hard to learn. However, the actual hard part about being a data analyst is the logic and thinking and problem solving that goes behind every decision you make. Anytime you're given a task as a data analyst, you're going to be told by your manager or a coworker or a director, here's the solution that we want. Can you do that? You have to say whether you can do it, how you're going to do it, how long it's going to take, and what this could mean for the business. Now, business users aren't going to always know exactly the intricacies of what you're going to have to do to pull everything together to make the product that they're asking for. So ultimately, the goal of completing this project is going to fall on you to figure out how you're going to get the data needed to complete this goal, how you're going to put everything together, and what tool or packages you're going to use to actually complete this. Not only this, but you have to understand, the impact that this is going to have so you can implement all the right things that directors or higher ups are going to need to see in order for this tool to be successful. So not only do you need to understand the intricacies and the skills that I talked about at the beginning of the video, you need to understand the final use case and exactly what this is going to be used for so that you can pull all the correct data, put it in the right format, and display it in a way that makes sense to other people who might not have the same technical background you do. Ultimately, being a data analyst is pretty hard, but the difficulty comes from problem solving, not from the actual skills you need to learn.
All right, 5 reasons not to become a data analyst. And if you stick around till the end, I might be fired up enough to give you a bonus one. All right, number 1, timelines. If you cannot work on timelines, you might not want to become a data analyst. Oftentimes, working as a data analyst, I'm working on stuff that I would normally be working on. I have ongoing projects that last a long period of time. However, sometimes during the middle of those, a request comes in that is urgent and needs done as soon as possible. Oftentimes, data analysts will be called by their managers or their directors and say, hey, I need this like this week. Can you do that for me? But at that time, you'll come and kind of estimate how long that's going to take and what additional information you're going to need. And usually this ends up becoming 1 or 2 weeks for this specific project that you're going to be working on. But either way, you're going to have a timeline. And sure, 1 or 2 weeks sounds like a lot of time, but sometimes working as a data analyst, especially if you're working with data that you aren't super familiar with, is actually not that long because you have to spend a lot of time looking at the data, understanding it, reaching out to people to ask questions who are subject matter experts in it, and you need to actually be able to use the data in context to the question that you're being asked. So anyways, timelines, for me, always get a little bit stressful, especially when they're close, and the stuff that you're working on is just a little bit new to you. But some people thrive on that, so I'll leave that up to you. Number 2, communication. And this is one that a lot of people don't think about, but coming in as a data analyst, you have to be able to communicate. The reason being, when you finish and get your results, your manager or your director is going to want you to share this with shareholders. Now, sometimes they'll be doing that. They'll make sure they have all the necessary information. But other times, you're going to have to present it yourself. And even if you don't, you still have to present it to your manager and director in the first place. So this is vitally important, and you need to be able to communicate effectively. This includes making clear the point that you need to make and easily explaining the results so that a shareholder or a manager or a director or a CEO can take that information and make a decision based off of it. Number 3, if you can't work with ambiguity, you probably should not become a data analyst. Sometimes your work is not always clear cut. Sometimes you don't know what your next steps are, and sometimes you just haven't dealt with this type of problem yet. As a data analyst, this comes up often, and you're going to have to find a way around it. I know this point in itself is a little bit ambiguous, so let me explain a little bit further. As a data analyst, if you're asked to work with a data set or a table or a location that you have not pulled data from before, it's going to be new to you. And sure, you can sit there and whine about it, but oftentimes there's a system set up that you can go find that information, or at least you can meet the people that will give you the right information. More times than not, this is the process that you go through when you're working with new data. You ask around, does anybody work with this? No. Okay. Do you know anybody who's worked with this? Yeah, one person, one of my coworkers knows somebody who worked with it in the past, 2 years ago. So you reach out to them. Well, they're no longer at the company, so you reach out to their old manager. This is the type of thing you have to go through sometimes just to get that information that you need. And once you get an idea, then usually there's resources that you can use rather than just cold outreaching to people. But sometimes you don't even know where to start. So that's something that comes up quite a bit as a data analyst. Oh, and hey, if you're enjoying this and you're thinking about becoming a data analyst, check out the 2 links in the description. I promise you, I'm not going to spam you. I'm not going to scam you. It's just a Discord where other people want to become data analysts and are interested in statistics majors. And then there's a newsletter as well that I send out once in a while. No spam. I just send out some additional information if it's on my mind. So check those out. And I think you'll really enjoy them if you want to become a data analyst. All right, the 4th one is if you don't like coding, you're probably not going to like being a data analyst. Some data analyst positions don't use much coding. They'll maybe use Tableau, they'll maybe use Excel, and that's kind of the extent of it. But a lot of data analyst positions are going to be using R, are going to be using Python. So you have to get comfortable with that, and hopefully you can get comfortable with that before you even start your job. Because if it's brand new to you as a data analyst, things could get pretty difficult. All right, number 5 is if you don't like documentation. And I mean documentation in 2 ways. First, you need to be able to document your code so other people can read it and understand what's going on. And second, you need to be able to document results. Similar to before how we talked about communication, you need to be able to write in an effective way that other people can understand what your results mean and what it means for the company. All right, and that one was short, so let me give you a bonus one so you don't freak out. And so the bonus is clean data. You have to be able to clean your data as a data analyst, and every single application you're going to be using, you need clean data. Oftentimes, when you pull it directly from the source, the data is not in the format that you need it for your application that you're working on. So you need to be able to transpose and select and filter and mutate and change and make new variables and join to other tables. You need to do a lot. I've made a video on it in the past, so check it out. Also, coffee jug.
A beginner data analyst needs to pick is a tool or programming language for data analysis. I personally started off with Excel. Is that the best tool there is for data analysis? No. If I could go back in time, would I have started with something else? Also.
So I like what he's saying there. I think Excel is a great segue into data analysis. If you don't have access to Excel, because Excel does cost money, Google Sheets is free and it offers a lot of the same capabilities as Excel. So if you're starting to get into data analysis, you could do some simple aggregations, pivot tables, make some simple visualizations. If you haven't used Excel or Google Sheets, I definitely recommend trying it. Even just doing a basic project in one of those can get your kind of feet wet and get you an idea of what you're actually going to be doing as a data analyst.
And I personally recommend every single data analyst to start off with Excel. It's easy to learn, used in almost every company, and it has a wide range of applications for data analysis. But this is also its pitfall. Although you can do a lot of different things in Excel, it's not designed specifically for data analysis, meaning it has its limitations. You want to work with a very large data set? Well, good luck not punching through your computer screen after Excel crashes for the 27th time.
Working with Excel with large data sets, it's not fun. Even if you're just using it as an intermediate step to look at data, you can't really load in large data sets even just to look how it's formatted or anything. So that's kind of unfortunate, and that is the pitfall of Excel. But like he said, it does offer a lot of basic capabilities and really the option and functionality to do a lot of different things. You can really do your first entire data analysis project from start to finish in Excel, and I think you would find that it's actually going to be very useful for you in your career. I know he said it was enough to land him his first data analyst role, but I feel like data analysis as a whole has become a lot more competitive. The requirements of the job, depending on what industry or what job or company you're going to work for, Excel might not be enough, but it's definitely something that you're going to want to know. And it's almost a rite of passage on your resume, I believe. I put Excel, I know how to use Excel on my resume, and they never mentioned it in the interview, but I did get the job, so just putting that out there too.
Excel is perfect for starting out, but once you've mastered Excel, it's time to move on to the more serious tools. And the most logical tool to learn next is SQL. Next to Excel, it is apparently the second most requested skill in data analyst job openings.
I do want to say, I don't know if SQL would be the next logical step for me, because SQL is helpful once you realize that pulling data directly the way it is, however, wherever you're getting it from, you realize that it might not be in the correct format. And SQL is going to be the best tool to get that data in the correct format. Until you know what type of format you need your data in, and you learn that by working in programming languages and working in different visualization softwares, which I know he gets to later in this video, something like Tableau or something like R or Python. and you need your data in a specific format to perform your analysis or to make a certain visualization, that's where SQL becomes really important. So personally, I don't know if jumping right from Excel to SQL is your best option. I would say jumping from Excel to something like R or Python or Tableau or Power BI or any of these other visualizations and data analysis tools would be the next logical step. But I'm never ever going to say that learning SQL is a bad thing, because I use SQL constantly in my job.
Because it doesn't have the same limitations as Excel. But the best thing about it is that SQL has its own very easy to use programming language. It's a great tool to add to your skill set as a data analyst, while also being a great stepping stone to some more serious programming. But before we get to that, every data analyst needs a visualization tool. There are dozens of BI tools out, but having worked for multiple companies and projects, and having looked at probably hundreds of data analyst job openings, I've come to realize that the majority of companies are looking for people with experience with Tableau, Power BI, and QlikView. Here's the pros and cons of each, so you can decide which.
Personally, I have heard of Power BI, and it's been used at organizations that I've been at. The easy visualization tool, I'll put quote unquote easy visualization tool that I have used, is Tableau, so I can speak a little bit about that. But it is definitely a beginner friendly, easy to learn, and easy to use data visualization and data analysis software. It's a lot of clicking and pointing, a lot of dragging and dropping. You're not going to be doing too much like coding, but you can make beautiful visualizations and you can get valuable insights from something like Tableau. And that's personally the next step I would be taking from Excel, and jumping from Excel to Tableau. You can do a lot of the basic things in Excel pretty easily. Once you get into more advanced stuff, it becomes more complicated than I think is what it's worth. And that's where something like Tableau comes in, because you can put your data into visualizations and add filtering options that just look a lot more seamless to an end user than an Excel workbook. But let's see what he has to say about these three, because I haven't heard of QlikView and I haven't used Power BI. So I am kind of interested to see what he says about those and see how those compare to Tableau.
Here's the pros and cons of each, so you can decide which suits you best. Power BI is part of the Microsoft stack, so it works smoothly with Excel and SharePoint. Besides that, it has a free version, and even the paid versions are relatively budget friendly compared to the other BI tools. Next up is Tableau. Tableau is a BI tool with more extensive data visualization capabilities than Power BI. It seems to be just a bit more in demand in the job market than Power BI. It comes with a much higher price tag though, making it harder to learn if you're starting out by yourself. There's QlikView, using in-memory technology, making it a super fast and responsive way of doing business intelligence, but also a pretty high price tag. And also,
I think QlikView looks kind of disgusting. Out of those three, I would say Tableau would be my choice, but I don't know enough about the other two. QlikView, from what he showed on screen, looked absolutely disgusting. But it doesn't have to look beautiful depending on who it's going to. But sometimes outside sources want your visualizations to just look nice. And it makes sense. The nicer it looks and the cleaner it looks, the easier it is to gather insights from. And that's an important concept to learn as a data analyst as well. But Power BI, I don't know enough about to say one way or the other. I know it's a Microsoft tool, and I know he said it in the video. Depending on what else your organization uses or where you're at in your career, a Microsoft Suite tool might be better. It might just fit seamlessly into your other products that you're using. I don't know, but Tableau works great for my job, and there is a small learning curve once you get into more advanced data analyst, not even data analyst, just like visualization techniques and understanding like the little nuances with Tableau. It is difficult. But there's another YouTuber who makes all Tableau content who I want to give a big shout out to, Tableau Tim. He's awesome. I've watched so many of his tutorials on Tableau. So if you want to learn Tableau, check out Tableau Tim.
Before we move on to how to actually get good at data analysis and land that first job, there's one more thing we need to do as a data analyst. After you've mastered a BI tool, it's time to get into the more advanced analytics. I'm talking about which programming language to use when it comes to data analysis.
But this is what I'm most excited about. I love using programming languages.
Java, JavaScript, Ruby, C#, Python, R, C, C++, and many more.
And I'm a terrible
Luckily
programmer, but I do
data
love it.
analysts, we only have to choose between two programming languages.
R and Python.
So which
Called
one should
it.
you pick? I chose Python. If I could go back in time, I
It's
would
almost like
choose
I watched the video.
Python. Why? Well, even though they're actually very similar, R is a programming language focused more on statistical analysis, while Python is a more general purpose program.
This is true. This is very true. R is more of a statistical analysis program, and Python is more of a general purpose programming language. R is becoming, I think, more and more closely related to Python. If you haven't seen our Shiny dashboards, I have a video. I can link it up above for anybody who's not watching live. I'm not going to go through and do that now. But I'm going to show you real quick like what our Shiny dashboards can look like. So this is something that was built in R, and that's all analysis. You can all filter on different things. You're going to see that a lot of them look similar because they're using similar packages, but you can even customize that with like CSS and HTML and to make them look completely different. Trust me, I've seen them much different than this rather than using the base R packages. But using the base R packages for Shiny dashboards like this is another great way to make visualizations and filter. And R is a lot faster at large data than something like Tableau. So if you're working with large data and you have to filter down on it and you have to filter on a bunch of different things, using something like R or Python's going to be the way to go. And the capabilities are completely customizable to you. You can fit models that you can't fit, or if you can fit them in Tableau, you can't customize them the way you do in something like Python or R. But that's just my 2 cents. I love R. That's all I used at school. So
programming language that also happens to be very good for data analysis. Meaning, if you get good at Python for data analysis, it might also open the door to a lot of different job opportunities.
I definitely have a biased view on that. I've also used Python for a previous role I had as a student researcher, and you can do so much in Python. And there's definitely a little bit more of a learning curve in R or in Python than there is in R. But I've used R so much that maybe I'm just biased in that sense that I think Python's harder just because I haven't dealt with it as much. But I don't think you can go wrong if you want to be a data analyst. Either one of these programming languages could be your first step into a programming language meant for data analysis.
So the path I took is Excel, SQL, Power BI, and Python. This is the path I would recommend as it worked out great for me.
But learning Excel or Google Sheets, interchangeable. I would prefer Excel, but Google Sheets works just the same. Learning programming language, R or Python. Learning a visualization tool like Tableau, Power BI, maybe ClickView. Those are going to be costly if you're working on it by yourself. But if your school has those softwares available, for example, my school, Penn State, had Tableau available to all students. Use that if you can because it's a great tool to learn. A lot of organizations use it. And then learning something like SQL. That was the path that I took. I'm not saying that's the best or the only path, but that's the one that I took, and I did get a data analyst job. Obviously, he took a different route, and he also got a data analyst job. So just keep those in mind. All right, guys, here's the resume that got me my data analyst job. We're going to go over exactly what's in it and exactly what you need in yours so you can get one too. Let's get into it. So at the top, we're going to have our name, and usually I would have my phone number and email there. Not super important, but let's go into the education and honors. So since I was just graduating college, I had this education and honors section at the top. However, once you go a little bit further in your career, if you have more experience than maybe somebody who's just graduating college, you can put that right at the top. And since I have some other experience that was more related to the job, I tried to keep this section short and sweet. So I started off with the university that I went to, Penn State, and I graduated in December of 22. And then I put the degree right under there, Bachelor of Science in Applied Statistics with an Information Systems minor. If you're proud of your GPA, you can include that. I don't think it's super important, and I don't think it's going to change the fact whether you're going to get a job or not. The next section is relevant coursework, so I took regression, probability, risk management and insurance, ANOVA, business analytics, intro to R and Python, and data science in R. So really for the relevant coursework, you're going to want to put only classes that relate to the job you're applying to. And that's why you're seeing risk management and insurance. I included that class because at one point I was in actuarial science and I'm applying to a health insurance company. However, looking back now that I'm in the job, probably I could have left off a few of these classes because they're not super important. For example, regression, ANOVA, not super important for my role, but really look through the job description, figure out what courses you had that relate to the job and include those ones. And then finally, if you have any honors or anything specific that you want to call out, put that there. I think that's important to show, and it kind of shows employers that you're pretty serious about your work. And so even though I started off with education and honors, I think if you have really important relevant experience, I think it would make sense to even move that above this section. Moving on to the relevant experience, I'm going to move my camera over so you can see everything. So the first one that I had here is my internship at the actual company that I was applying to. So after my internship, I wanted to stay there. I really liked the atmosphere in the company, so I applied to the same company that I interned at. So here you can see I was an analytics operations intern. That was my job title as an intern. Now, since I was applying to a data analytics role and my internship was really focused on software testing, I just called out the specific parts of that job function that related to data analysis.
So you can see the first line, testing and documenting technology upgrades such as SAS Via and Trifecta. Those are just specific technologies that as the intern, we had to test and make sure that the new update wasn't going to screw up anything with our existing kind of workflow that we had at the company. And so since I was testing technologies that was actually used in these analysis workflows, I wanted to call out specifically that I had experience using them and testing them and a lot of the different functionalities within those tools. The next thing was to show that I also had experience with Python. I wrote a lot of Python scripts that automated the cleanup of servers of unused files and automate file archival process. So that's pretty important at a company like this because you could imagine there's so many files being passed around, and it's important to be able to clean up old ones that just aren't used anymore and archive them so that people can find them pretty easily. And then finally, I also helped with some analysis in this analytics operation internship. I helped convert some existing dashboards at the company into R that were previously in things like Tableau or SAS Via. And now this one actually related directly to the role that I have now because that's something that I still do. And I think that was an important call out and an important thing to include on the resume. And so I had my internship at the top because that was the most recent. But prior to that, I was also a student researcher at my college. So in that research position, I did things like utilize Python with a bunch of the packages that I call out there to perform various forms of advanced data cleaning and analysis, machine learning operations on large data sets provided by sensors on injection molding machines. The rules still apply. I know how to do analysis. I was using Python. I was using a lot of different packages in Python, and I was performing a lot of different operations there. I also got to dip my toes into some machine learning and data analytics, so that was directly applied to the role that I was going for. And this position was pretty unique because I was able to mock up some of the research that I had done into documents that was shared within my school. So I could also show that not only I know how to do it, but I can also explain it to other people in a way that they can understand, which is very important for data analytics. So again, I'm showing that I know how to do things that are related to the role, and I know how to explain them to people. Those are all important things when you're becoming a data analyst. And so if you don't have relevant experience like this, I highly, highly recommend that you try your ass off to get positions like this because it's super important on a resume, and it helps show that you actually know what you're doing, and you're not just getting by in school. All right, so let's move on to the skills section. Now here, I just wanted to call out anything that wasn't called out above. I called out some of the programming languages that I know. Python, R mainly, some HTML, some SAS, some C++. With all of that knowledge, with all of those languages that I did have experience with, that also shows the ability to learn new languages quickly. So if this role uses different language or the team uses a different language or tool, that I can learn it and pick it up pretty quickly. So next I called out some specific machine learning that I learned within my previous roles and in school. And then also I call out any data science or data analytics specific skills that I have. So data analysis, statistics and modeling, regression, classification, clustering. I've worked with probability and time series analysis, hypothesis testing, all the basic stuff that you would get through your statistics major or in a previous role related to data analytics. And so it's important to call out any of the other technologies you know. You can see I have Tableau, Excel, Git. Those are all other technologies that I've used within previous roles or within previous school experience. All right, and then finally, another important section is the projects and leadership section. So here, you want to call out anything specific where you took an actual leadership role or you led a project or did a project on your own, because you can show from start to finish exactly what you did, maybe a little bit about the process and what you learned. So the first one I had was taking lead on an R-Shiny dashboard development. That was in my internship. So I was converting an existing dashboard that existed in SAS Via into an R-Shiny application. And I knew this was an important thing to call out because in my specific position, we were converting a lot of these dashboards over into, open source technologies such as Python and R. And that was important to call out because I knew that would be something that would probably come up in the role that I was applying for. With something like R or Python, you have a lot more power than using something like Tableau or SAS Via to create dashboards. You can see that I said it improves the efficiency of the dashboard in updating user inputs, and it improves based on those other technologies because R and Python, being open source, have a lot more capabilities than some of those other programs. And the next thing was calling out some of my specific statistics knowledge that I've applied in my previous roles. So implementing statistical process control, or SPC, on my smart manufacturing research team that was at my school. So I took lead on implementing SPC for the project and utilized Python to do so. So I showed that I had specific statistics knowledge that would possibly be applied to a data analytics role. And I also called out that we were presenting these results to team members and to the sponsoring organization that we were working with, because that's an important thing as a data analyst. You're always going to be presenting your results to either your team members or managers or stakeholders, and that is a vital part of the position. So if you don't have experience doing that, I would try to get some. Maybe present your research in a video, or present your research to some of your friends or team members or classmates. If you want this resume template for yourself, go ahead and check the 2 links out in the description. One's to the Discord and one is to my email list. I'll be adding those over the next couple days.
It's been about a month and a half since I graduated with my statistics degree, and about a month since I started as a full-time data analyst. And from that month of experience, I've learned a few lessons that will help you get a data analyst job in the future. Now, what I realized after this first month of becoming a data analyst is that you're going to be using SQL all the time. I would say within the first 30 days that I've worked as a data analyst, about 90% of those days I was using SQL. And at first, I had very little knowledge of SQL. I had used it in one class for maybe a couple of weeks, but that was all the experience I had. So I kind of had to learn from scratch. In the past month, I became pretty well acquainted with it. But if you can learn that in school and say right in your job interview that you know how to use SQL, you're really going to separate yourself. Now, I'm not too sure how you would learn this on your own, but I'm sure there's plenty of resources here on YouTube where you can learn how to use SQL. But if you want to be a data analyst, I would highly, highly recommend trying to learn it on your own. And to me, the hardest part about SQL isn't the actual syntax or what you're doing, because if you've used Excel or used R and you've manipulated data in the past, everything's going to be along the same lines. Now, syntax definitely is different and you need to learn that, but I think that's the easiest part. The hardest part about learning SQL is really more job specific, and that's understanding where different types of data sit in your organization or wherever you're going to be working, and how you can pull all of those together and morph them into one and make new variables and actually get valuable insights from that data. I mean, that is what a data analyst does, I suppose. But the second thing, and somewhat along the lines of the first one, is problem solving. Now, I would hope as you're going through college, you're learning a lot about problem solving in the various classes that you're taking. But to me, problem solving is a little bit different. Sometimes as a data analyst, you're going to have your managers or your stakeholders ask a specific business problem that they have or a specific finding that they want to find out. Your job as a data analyst is taking this objective or this business problem that you were given and breaking that down into different steps that you know how to solve. Now, on top of this, you're also going to need to understand the little things about this problem that might make it more difficult to solve. For example, the problem they're asking you to solve, you might not have a super quick or easy way to solve that. You might need to join 2 tables. You might need to exclude some data because it just doesn't make sense to include them in your analysis. That's the type of problem solving that I'm talking about. But the way I think you can learn this while you're in college is find different data sets on the internet that are free to use and ask yourself specific problems about that data or specific objectives that you want to find and figure out how to solve them on your own. If you can bring that up on an interview or put that on your resume, that actually shows a lot more than just saying, yeah, I got an A in this class. Because that doesn't mean too much because you're given kind of clear objectives and clear goals in classes in college. And I think that if you can say that you went out on your own and you came up with a business problem or a problem that you were trying to solve, you found the data sets for it, and you figured out a solution to that problem on your own, that shows so much more ability to learn than just getting an A in a class. And somewhat along the same lines, again, is the third one, which is you have to be quick to learn new techniques in software. The first thing I realized as I started full-time at this company that I was working at is that they use so many different softwares and different techniques for different things. And sometimes they even use multiple softwares to accomplish the same thing. So for example, at my organization, one team might be using R, one team might be using SAS, and another team might be using Python. And sometimes you have to take things from other teams that they've done in the past so that it saves you a little bit of time and figure out how to translate that into a different language. This is something that I've already had to do a few times, is take things from SAS, which I don't have a ton of familiarity with, and turn that into R code or turn that into Python code. So if you have the ability to take things from one language or one software or one technique and translate that into how it can solve a problem for you, that's going to be a big plus. And I think so by using a bunch of different softwares in college and trying to combine that knowledge into one knowledge base or database in your head that you can pull from and extract from and show that on your resume or in your interview, you're going to have a leg up on the competition in getting a data analyst job. And now finally, the weird thing that I noticed about being a data analyst is that you're not using a ton of math or statistics. So for me as a statistics major, that was kind of weird to find out. But a lot about what I learned about being a data analyst is the majority of your job is problem solving and cleaning data and figuring out which data you need. Now, there is definitely some statistics and math that goes into your actual analysis, but your actual analysis is going to be a lot smaller of a percentage of your job than those other things. So if you're in college and you're stressing about your math classes and you're stressing about your statistics classes and you want to be a data analyst, I wouldn't worry too much about that. But it is important to understand, because once you get to that analysis, you actually have to take all that work you've done up to that point and turn that into real analysis, real math, and real insights for your company. This video is going to be for anybody who's still in college and wants to be a data analyst, and you're kind of looking for a roadmap on how to get there. I think I'm qualified to talk on this because I just recently graduated from college and started a data analyst job. I think it would be most beneficial for you if I started from really the beginning of the data analyst journey. So my data analyst journey kind of started out when I was a junior in college. Going into the summer after my junior year, I realized that I was really going to need some kind of experience. Up to that point, I've only worked at like a pizza shop, I've worked at Lowe's, I've done a bunch of random stuff, I did roofing, but I needed some real experience to get out there in the job world. And that first opportunity actually came by chance. So this is the first point for you. Try to put yourself in situations where you can get these opportunities. So for me, that was being in the math group at a branch campus of the college I went to previously. I received an email from the math club because they never took me off the list. But anyways, the email I got said, we're looking for somebody with statistics or coding or programming experience, whatever, for an engineering role over the summer through the college. So I'm like, this is perfect for me. But when I talked to the professor who was running this research program, he kind of laid out what we were going to be doing. They needed somebody with analytical experience, and me being a statistics major, I had quite a bit of analytical experience under my belt. Now, I wouldn't say I was a master by any means, but I will say that I had enough to talk my way through the interview. They were looking for somebody who knew Python, which I had very little knowledge of, which I kind of explained to the professor, but he was completely okay with it, that I had seen it and I have done other things in similar languages like R. And so just by putting myself in that situation where I was in this group, I could receive opportunities like this. So I just saw that email and I immediately applied. And the turnaround was actually really quick. So it wasn't like I was actively going out and looking for roles, which I was, but this one kind of just fell into my lap. So make sure you put yourself in situations where you can get these kinds of opportunities. But that research position was valuable for a couple of reasons. One, it kind of taught me a little bit on what you would actually be doing in a real analytical role. And when people tell you that cleaning data is going to be 90% of your job for a data analyst or data scientist, take that to heart because it's really the truth. But anyways, a lot of this time was spent cleaning data off of manufacturing machines, which is absolutely disgusting. The data was not formatted correctly in any way. Sometimes it was just flat out wrong and the readings were wrong, and you had to fix that and talk to the manufacturer and figure out actually what was going on. So that was valuable because that's going to be, like I said, 80 to 90% of your role when you're a data analyst. And then the second part of it is I was working with a computer science student on the project, and he was using a lot of machine learning techniques. So that was something that I could also leverage. This not only introduced me to machine learning, but it also gave me a sense of what was actually going on behind the scenes in practice when you're using it. So these were two important things that I could talk about now on an interview. And the nice thing about this research position is it was an ongoing one. They wanted to continue it. They liked where it was going. So I did that for an entire year almost, that research position. And then when it was coming to summertime, offered me to stay again over the next summer, but I wanted something, in industry. Now the research position was great. I was working with a real company, and even though I was working for the school, I was still doing real work in my opinion. But I really wanted to put on my resume that I worked for, a quote unquote real company. I told the professor this, I might come back, but I'm really looking for something in an industry, and he was all for it. He said that's a great idea because it's going to make you more attractive to employers, which is ultimately what you want out of college. At least that's what you should want if you don't want to waste your money. And so I applied to about 100 to 150 different positions, most of them internships, some of them co-ops. But I was really just putting my name out there and trying to get as many applications as I could out so I could get a few calls and get a few interviews. So unluckily or luckily enough, however you want to look at it, for me, I only got a few calls back. One of them was just an absolute dud. I didn't even like the company. The interviewer was late. That was annoying. But that's fine. I don't want a position like that where the employer is not going to respect my time. But luckily for me, there was a local company. I got an interview and I kind of did really well. I had a few different interviews for different positions in this company, but this one went the best. And I ended up getting an offer. But that's not the one I took. The one I took was for a different company, a bigger company out of a different city, but it was all going to be remote. And I'm thinking to myself, well, I can take the one that's local, and I'd have to go there, and I'd probably, if I end up getting a job, I'll probably end up working there forever. Or I can take a chance on this other company that I've heard of. I know it's a big company, and if I get a job there, I'd probably get paid more. I would probably have more opportunities open up to me in the future, and I think the opportunity for growth at this company is just way better. But the thing was, the pay is the same, so why not take the risk, right? And at that point, I thought of it as a risk, but really it was the best decision I could have made. So I take this position going into my last semester of college, which was just ended in December. I'm going into this internship and I'm thinking, well, okay, so I don't know exactly what I'm getting into, but this interview for this position, they asked me so much about R, which was super exciting to me. And that was part of the reason why I wanted to take this role, because I'm thinking, well, if they're asking me all these questions about R and why I'm using it and how I'm using it, they probably want me to use it, right? And I'm very comfortable in R. That's all I used in statistics, really, my entire time in school. So I'm thinking, you know what, this might be the right position for me. And that was something they were looking for too. So they also liked me as a fit for the position. And thank God for them. The two managers, they were awesome. And I still talk to them today because, well, I work there now. But I leveraged so heavily on that research position, talking about R in school, and then also how I used Python and all these other programs as in my research position in the previous role at the college I went to. So they really liked the interview, and I think it went well, and they ended up giving me an offer. So I interned there over the summer, and I'm going into it thinking, okay, I really want to, impress my employers. I think I would like it here. I want to go into it with an open mind because I didn't know much about this company. I've just heard of it before because it was so big. Going into any internship, you really want to make a good impact. I don't think all college students go into it with the same mindset, but that is one of the most important ways that you can get a job, especially if you want to stay at the company that you're interning at. So I go into this, and it was nice because it was a different kind of role. It wasn't really an analytical type of role. It was more of a testing role. So I'm testing R, I'm testing all these different programs for this company, making sure they're well documented so people who want to use them know how to use them. If they run into any trouble, they know how to fix it, and if not, they call our team for some help. That was interesting in its own right because I got to use all these different programs that I had never had access to before, and some that I had never even heard of. And through this testing, I gained a lot of experience in analytical work because some of them were analytics-based tools. I learned a lot about databases because there were some database-oriented tools. So, getting data to flow from one part of the company to the other and having it in data lakes and being able to pull from there and how to pull in these different programs, that was super valuable because if you think about it, that's what you're doing as a data analyst or data scientist anyways. And so as I go through this internship, I'm doing pretty well, and I think my managers were really liking the work that I would do, and they wanted to keep me there, but they knew that I was more of an analytics focused person, and that's kind of what I wanted to do. Luckily for me, those managers helped me look for other positions in the company once my internship was going to be up. And so when I interviewed for some of these analytical positions that I was applying for, I was able to leverage not only the research position prior, where I was doing real analytical work for a company in Python, I was also able to leverage all my knowledge in R that I learned in school. And I was also able to leverage all these other tools that I learned in the software testing internship I did. So that was 3 tools that I was able to talk about in my internship that I have done. And it also shows that I'm fairly capable at learning new languages and new techniques pretty quickly. So in the end, I get this analytical role and I love it. And I was able to leverage all these little things that I had done in the past to gain myself experience and kind of cut my teeth on these new analytical tools and all these different programs.
All right, in today's video, we're going to be talking about the truth about majoring in statistics and how that relates to my job as a data analyst. We're going to be talking about the most underrated data job there is, and hint, it's not a data scientist. We're going to also talk about how I use ChatGPT as a data analyst. And finally, I want to reiterate a point that I've made in the past, but I think it's so important when you're trying to find a job that you can really emphasize this point. So the first thing I want to talk about is the truth about majoring in statistics and how that relates to me being a data analyst. The truth is that I don't use 90% of what I learned as a statistics student. And it's really unfortunate, but it's just the truth. Out of my job, most of what I do consists of SQL, it consists of R, and it consists of Tableau. And now I do a lot of presentation, a lot of communicating, but out of all those tools, I'm not doing a lot of pure statistical work. A lot of the work I do is data cleaning, pulling data, making visualizations, putting them into a dashboard. Now, if that doesn't sound exciting to you, maybe a data analyst isn't for you, but at least for what I'm doing as a data analyst, I was expecting to do a little bit more statistics. Now, I do want to insert a caveat here because I do work with a lot of people who do use statistics a lot more so than I do. I work with actuaries who use statistics all the time. I work with statisticians who obviously use statistics all the time and are performing statistical tests on hypotheses that they have. But personally, as a data analyst, as an entry-level data analyst, I don't think you're going to be using a lot of statistics. I think you're going to be using those skills that I talked about a second ago, SQL, R, Tableau, maybe Power BI, maybe some Excel, data ingestion, meaning data engineering, that kind of work. You're going to be doing a lot of that, and you're probably not going to be doing a lot of statistics. So if you are on your own statistics path and you're really highly focused on statistics, I'm not saying that you shouldn't focus on it because good grades are important and that it reflects on your resume. However, I am saying that just be prepared that your entry level role, you're probably not going to be using a lot of statistics. You just have to keep that in mind when you're searching for jobs. If that's something you want to do, then maybe you should be looking for more of a research role or more of an entry-level statistician role. Good luck finding one of those. But for me, the statistics work I do use is the basics. The stuff you learn in high school, the stuff you learn in elementary school. I don't know whenever you learned it. But means, medians, ranges, that kind of thing, that's about the extent of the statistics knowledge that I use. However, I will say, since I do work with a lot of people who use statistics every day, I am interacting with statistics. I'm just not using it in my day-to-day role. But if you want to be using statistics, an entry-level data analyst role, probably not going to be your best bet. So just keep that in mind. But that brings me into the next point, because if I'm not doing statistics all day, what other kind of roles or hats or things do I have to do on a day-to-day basis that doesn't involve statistics at all? And that brings me to the most underrated data job that not a lot of people talk about. However, this one is very popular. It is very high paying, and it is very high in demand. And it's not a data scientist, or it's not a data analyst. It's a data engineer. Now, if you aren't super familiar with the data field, what a data engineer does is basically they get the data in the correct format for use for all the other people I just mentioned. Software developers, analysts themselves, any kind of analyst really, data scientists, whoever else is going to be using data. They ingest that data into a particular location, or usually a database, and they get it into the correct format, they clean it up, and they might pull it into your project for you. However, as an analyst or a data scientist or a business analyst or software developer, you might not actually have access to a data engineer. You might have to learn how to do some of that on your own. And so about 50% of my work, at least to start over the past 2 months, has been that. It's been data engineering. So I take the raw data for wherever it comes from, I pull it into the application that I'm using, and I have to format that data and get it out of its ugly, nasty format. I have to get it for the correct time period I want, the correct rows I want, and I'm using where clauses in SQL to get those. I'm joining two tables together so that I can get all of the data that I want, not just some of it. And sometimes that work goes past just SQL. I have to pull in a certain part of it using one SQL statement from one location, grab another from another, and then I'll join those in R so that I have my final data set. Once I have my final data set, I might be doing something different with that. I might be writing it to a different database. I might be pulling it in and saving it to my local hard drive to use on a different project or in a different software. But a lot of what I do is data engineering. And I've realized that a lot of what anybody does that I work with is a lot of data engineering. It might not be data engineering in the classical sense, like if you look up what a data engineer does, but it is data formatting. And you need to understand that no matter what role you go into, if it's an analyst, if it's a data scientist, if it's a business analyst, a software developer, and you're working with data, you're probably going to have to do the same thing. And it's going to take up a large percentage of what that project actually is. Now, I told you what you might have to do, and I told you what I did, but how do you actually do it? The simplest way I can put what data engineering actually is you're taking data that's untidy, sitting in different locations. The date times are showing up as integers and you need them as date times. Maybe you need to calculate another field that you want and you know how to calculate that, or you don't know how to calculate that. Data engineering is the process of taking all of those separate pieces, putting them together, getting it into a tidy format so that you or somebody else can use that data and it's accessible and easy to understand. So what goes into this is the knowledge of SQL or a tool in another tool, something like SAS or R, to actually put all that together. And then the other part of it is you have to actually understand the data. And this is hard, especially if you're just walking into an industry or a company. They're going to have their own processes for storing data, and you have to really understand that and understand what the underlying data actually is telling you. And there might be some resources at your new company or wherever you're going to be on how to understand this data, like resources that tell you what these fields actually represent. If you're trying to pull for a particular purpose, how you would do that. But if you don't, you're gonna have to figure that out on your own and ask a bunch of questions. But it does take a long time. Just keep that in mind. Data engineering, super underrated. And if you're interested in data at all, this might be a career opportunity that you can look into. Also, if you've made it this far in the video and I'm talking about statistics and data analysts and all these different data jobs, if that's the kind of thing you're interested in, you should probably consider subscribing to the channel because I talk about stuff like this all the time. But let's get back to the video. But now that we have our data in the correct format, your data analyst, such as myself, what if you don't know what you're doing as a data analyst? So this is kind of my segue into how I use ChatGPT as a data analyst. Now, I want to say this beforehand. I don't use ChatGPT for every one of my tasks. There's no way. It's not that perfected yet. However, I will say there has been 4 to 5 cases as a data analyst where I've used ChatGPT to solve a problem. And the most common case for these is that I have some kind of complicated code that I just don't really want to take the time to think through and map out how I actually have to write that. So I go to ChatGPT and talk to ChatGPT like I'm talking to a coworker. Also, fair warning, don't ever put like what your actual data is in there. Just don't do it. There's safety concerns, obviously. But you can craft a test case in your head that represents what your data actually looks like. But I'll say I have this case, I have these 3 columns, and I want to check these 3 columns for certain values. If all of this is true, then make a new value that says blank. And for all of these different cases, I've had a few different cases with a similar setup to that. All of them, I've either reached my goal and actually completed it, or I've partially reached it and then been able to figure it out on my own through ChatGPT. So one of the specific cases I remember is similar to how I set up. You have 3 different columns. You need to check all those 3 column values. And it's a very complicated if-else statement with a bunch of different clauses and if statements and else statements. It's disgusting. So I just didn't want to logic myself through it. I just wanted ChatGPT to do it for me. And after 4 or 5 back and forth with ChatGPT, it gave me a usable format that I could start with, and then I could put in my own column name and put in my own data, and it would actually go through and do that. Now, it took a little bit of reformatting and a little bit of troubleshooting, but I had ChatGPT set me up and put me on the right path to completing this goal, and finally I completed the task and got that extra column that I wanted. So if you're a data analyst or you're anything like that, ChatGPT is not going to answer your questions for you. You can't have no idea what you're doing and have ChatGPT tell you what to do, because if you do that, you're going to get something wrong and you're not going to know why. The nice thing about ChatGPT for me is that I have a pretty good idea what I'm doing in R. And so if I ask a specific R question and maybe I have a decent idea on what I would do, I just don't want to, go through the process of going to Stack Exchange saying, how do I do this? And then pulling that and trying to apply it to my own situation. I'll set up my situation with ChatGPT. I'll ask it, or I'll tell it what I want it to do. And then I'll ask it, can you tell me how to do that? It says yes. It'll show me something. I say, that doesn't look quite right. Let's try changing this column to this. And I actually wanted to say, if this column equals this value, then this. And then it'll reiterate and go through again, and it'll type it out, and it'll explain its code. So it's actually just like talking to one of my coworkers, like, hey, I have this problem. Could you help me? And that's kind of how you have to approach ChatGPT as an analyst or a statistician or anything like that. But it is a great resource, and it is a valuable tool. If you haven't tried it yet, go ahead and try that out. And now finally, I want to reiterate a point that I've made a few times, and it's one of the most important things I have to do as a data analyst, at least in my opinion. But it's going to be something that's going to come across whether you're a statistician, a data scientist, a business analyst, a project manager, a software developer. You're probably going to have to present. I bring this up today because I actually had a presentation today, and I constantly have meetings at work that I have to talk to a bunch of different types of people. I have to talk to end users. I have to talk to other analysts. I have to talk to my managers. So communication, I need to reiterate and stress that communication is one of the most important skills that you're going to have as any type of analyst or data role. So a little bit of backstory on the presentation I had today. I'm helping build a tool, and I need to display this tool and showcase how it's actually going to help other analysts on the team. So I go into the tool, me and my coworkers, we are presenting, and we need to come up with a use case for these analysts that they would actually use in real life. The goal of this is to show that the tool we're building is useful and that they can use it. So they need to go in, give us feedback, try it out with a specific use case in mind, give us feedback on the tool's ability to answer that question. So you can't just go in and say, yep, here's the tool, here's what it can do. That's not really impactful. If you want them to use it, you should come up with a use case that this specific group of people would actually do. So that's what we did. We defined a specific business problem that they have tried to solve before, or they have solved before, or something similar to what they've done before. And then we went in the tool that we're building, and we're like, okay, let's set up the problem. We're looking at blank population with blank issue and living in blank. Okay. So then we go in and we're like, okay, here's this problem setup. Here's how we would do this in this tool. You go through, you select this population, blah, blah, blah. And then if you want to look at this information, you go to this section and you have these different options in this section. But if you want to look at this information, and you click this section. But the ultimate goal here with communication is that you need to showcase value. You don't just want to be talking and umming and humming and hawing. You want to display value, and you want to give a sense of specifically what your problem is, or how you're going to help somebody, or give clear answers to a question that you're asked. Partially, that was the reason that I started this YouTube channel. I wanted to work on my communication, and I'm hoping that for people who are watching these videos over and over again, you're seeing my improvement in communication. At least that's what I hope. So ultimately, you're looking to provide value, and you want to get to your point as concisely and as clearly as possible. So you don't want to go on a random tangent that really doesn't mean anything. You want to get bullet points, and if you need more clarification, you can dive in a little bit deeper, but you want to showcase the value up front and then ask for questions and feedback after that.
So here's how I spend my data analyst salary. I get paid every 2 weeks, and I get paid around $3,000. First things first, I gotta pay Sleepy Joe his $600. This includes federal taxes, state taxes, local taxes, blah 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 taxes. We got taxes for everything. So that leaves me with about $2,400 left. Now on to the fun stuff. So starting off with my 401k. And so every 2 weeks I contribute $145 to my retirement account, and now we get into some of my insurance. First, a whopping $4 comes out for my dental insurance, a whopping $2 comes out for my vision insurance, and $40 comes out for my medical insurance. And the final thing in my pre-tax deductions is my HSA, which is a health savings account. I contribute about $55 every paycheck. So a health savings account, if you don't know what that is, it's just like a debit card that I get, and I can use it for any health care purchase. So if I go to the dentist or the doctor and there's like a copay involved, I can just swipe that. But it comes out before I'm taxed on it, so it's kind of a nice thing to have. And so all these other pre-tax deductions, including my insurance and health savings account, that's another $245 off of that $2,400, which leaves my take-home pay to around $2,100 every 2 weeks. Now for my personal expenses, the first thing I do when I get my paycheck is take about $1,000 and I put that right on my student loans. I just recently got it under $20,000, so I'm pretty happy about that. So it'll be paid off within a couple of years. So my take-home pay immediately becomes $1,100. I'm a big believer in paying off my debts as soon as I can. I follow the Dave Ramsey plan. So if you want to see a dedicated video on that, let me know down in the comments. The next thing I do, I live with my fiance and her parents, so I give them $50 every paycheck, just as a little bit of a rent payment because I'm here and I'm using, toilet paper and stuff like that. I'm also responsible for getting groceries and making dinner a couple of nights a week, so that comes out to about another $200 per paycheck. Of course, everything's really expensive right now. Food is off the charts, so that kind of adds up pretty quickly. And finally, some miscellaneous subscriptions that I have. I have 2 gym memberships. I have a subscription to a video editing service that I use for this channel. I have my phone bill, and then I have my car insurance. And this comes to about $145 every paycheck. And so finally, that leaves me about $700 for discretionary spending. Now, usually I try to keep this in my bank account in case anything comes up over the 2 weeks until my next paycheck, but I can kind of spend it however I want. Sometimes I'll take my fiance out to dinner. I love to go golfing, so there's $20 or $30 every few days. But if I have anything left over by the next paycheck, I try to contribute a couple $100 to $300 into my Roth IRA savings account as well.